Alrighty, so I'm Jim, and on the line is Samantha, who helps with students and student projects, and kind of get on my calendar. Melissa for everything else, uh, and Melissa can also handle any faculty that are on a call, demos, trials, um, courseware, things of that sort. So, okay, let's keep moving through this, and the agenda today is really kind of taking the PICO question, which is kind of the standard bearer in DNP research, and really getting the data analysis plan. That's the critical thing, one critical thing. Um, Certainly, we have to talk about levels of measurement briefly. You have to know the three kinds. We have to talk about how to put your aims in statistical language, how we then select the correct test based on that statistical language and that aim. They go together. Setting up data. Most folks are doing paired t-tests. I need to relook at the literature, but the last I've seen, 80% of folks were doing paired t-tests. I want to touch briefly on the differences between clinical significance and statistical significance. Statistical significance being that p-value of 0.05 that's out there, and clinical significance, which is kind of talking about the importance of any differences that are found. Okay. We'll talk about data cleaning, conducting results, and discussion draft. A lot of folks don't know that that's in there. So if you don't know, I can draft a discussion chapter for you as well, based on your results and tapping into the existing literature that's out there. So that's a real win. It doesn't cost an extra penny, just 2 minutes of your time, and it will save you 20 hours. And then we'll do some live demo and walkthrough. If you have questions during this time, you can put it into the chat. You can put it into the Q&A. Do I have the Q&A open? Let's see here. So either one of those forms are fine. And okay, so PICO questions. Typically, this is like this. If someone had to create and say, you know what, let me just make this thing as comprehensive as possible in one question and talk about the population and the setting and all the other things, they would have developed the PICO. And that's what you guys have, okay? Uh, you know, I'm a much simpler person, like really like what are the variables and how are they related? But the PICO talks about everything. So, but at the end of the day, you want to get your PICO down, okay, in the spirit of getting to a data analysis plan and then executing on that plan. You want to get it down to what are your variables and what are you seeking to do with them? I want to predict one from the other. I want to see if there's differences. I want to describe whatever. So at the end of the day, I'll call it, PICO light. You want to get to that kind of core, the population is not in there, okay? We're assuming that population is in there or that sample of that population is in there that we're collecting data on. So that doesn't really drive the analysis. And what folks get stuck with is the analysis. So I'm going to talk about the variables and the relationship or differences between or among those variables, okay? The data plan, where most people get stuck, is really putting that aim in statistical language. Are there differences or relationships, or predict, or does one predict another? Okay, kind of language, and then levels of measurement, nominal, ordinal, scale. Okay, so those are the two ingredients to get that to that data plan. Okay, so let's talk about levels of measurement. There's only three of them. Nominal is just purely names of things, red block, blue block, red block, okay? Male, female, there's no hierarchy. and they're just names of things, okay? Ordinal, and it has that icon, by the way, that Venn diagram um, uh, icon, which you will see in the tool. The next level is an ordinal level of measurement, which has labels, 1 degree, 10 degrees, 100 degrees, but it also has an order, okay? There's a lot of variables that have that. And then there's scale, which has the trifecta of names, okay? 1 inch, 2 inch, 3 inch. It has an order, 1 inch, 2 inch, 3 inch, and it has equal spacing or equal volume, equal time in between those things, okay? So, and that icon is the ruler, and there's lots and lots and lots of variables that have scale level. Um, Scale level is what we call it, okay? Um, Continuous level variables, ratio level variables, interval level variables, these are all synonymous because they do not impact the analysis, okay? So, so we're going to call it scale, but just know that those other synonyms, or I'll call them synonyms, are the same, okay? So, individual items, let's talk about, and people get hung up on this, but it's, is a Likert type, and I think the correct pronunciation is Likert type, or Likert type items, ordinal or scale, okay? So, the rule of thumb is this. If your Likert type is 3 to 4 points, and you're just using that one variable, okay, keep it as ordinal. If, however, it's 5 to 7 points, uh, then you can really really well 5 to 7 points. I would use it as a scale variable. Um, yeah, we change that. So 5 to 7 points, you really use it as a scale variable. Okay, that's a typo there. When, however, you're using 3 point scale, 4 point scale, 5, 7 points Likert scale, okay, and you start averaging them or summing them, you are now in scale level world, okay? So, and my common example is when you take a test when you're a kid and you either get it correct or incorrect, okay, that's nominal level, okay? But once I start adding, okay, those 10 items, I am now in scale world, okay? All right. So, and this is mostly the case over here, by the way. So whether your instrument is um, any kind of ordinal level Likert scale, okay, you're going to be averaging them or summing them, okay, and then you're in scale world. All right. Um, Study aims in statistical language. Basically, I bucketed them into differences, relationships, and prediction. This does not carry the whole, okay, corpus of analyses, but it does a very good job at capturing, 90% of them. So the differences question, and probably what most of you are looking for, are really differences in kind of two ways. Some pre-post differences, okay, on knowledge or some outcome variable or self-efficacy or confidence or whatever, okay? So really individuals are getting a score of confidence at pre, they get a score of confidence at post. We want to see, did our intervention or education make a difference there? Terrific. The quick side note there, when you and I hear this, when you are doing pre-post tests, you have to get a common ID, okay? At the beginning, at the end. Sally took it at pre, This is Sally's post-test. Okay, they have to be matched or paired. So people say, well, it's supposed to be anonymous. That's fine. Put down your dog, put down your mother's birth date. They're not going to be able to track your confidence scores like anybody cares. They're not going to track your confidence scores based on your dog's name, okay, and your mother's birth date. So do something that you can match these things, okay? Uh, don't say it's anonymous, therefore I could not do that. Put down some random number that someone's going to remember pre to post that you can pair them. You can wind up doing things and considering them different groups, but that's not really correct. So the better thing to do is to have some number or alphanumeric kind of code or ID pre and post that you can match these folks. Once you're in looking at differences, okay, I'll stay with this for a second. So most of these things are scales pre to post. Use a validated instrument, by the way. Don't make up your own thing, okay? Qualitative, you can make up your own thing. In quantitative, you don't want to make up your own thing. One, if you start making up a scale, a reasonable question is, how do you know that your scale is reliable and valid? How are you going to do that? You can look at reliability after, like with the Cronbach Alpha, but how do you know it's valid? Well, I had people look at it who have knowledge about it. I compared it to some other, okay. So that's one good reason to use a validated instrument. The second reason is just like, what are you doing? The people come, I could not find a scale, okay. And I say, okay, out of the whole planet, out of all of these researches, no one has assessed this variable aside from you? How can that be? And you're going to now create the scale in your DNP? No, don't do that. So you should be thinking about, why is that? How is that possible that there's no scale available on the planet at all time? Okay, that's a question. All right. The other kind of practical reason is that when you go to do a discussion chapter and you have tap into literature, you'd like to have some other literature based on that scale, okay, that it agrees with, it disagrees with. There's a tension in some aspect, okay? So those are good reasons to have validated instruments. Even if you have to adapt it, okay? Hey, it talked about teachers, but now I'm dealing with parents or whatever. Okay, you can adapt the scale and still carry over the gist of it with respect to reliability and validity. Okay. Okay. The other kind of differences thing that I see is there a difference in percentage? Okay. All right. Did the fall rate change? Did the infection rate decrease? Whatever. Okay. And you're really dealing with rates or percentages or ratios. No problem. the the this latter case I'm talking about, we're really into two proportions z test. Okay. Okay. So I'm testing this proportion of false, okay, compared to that proportion of false. All right. The more common is the earlier, which is these differences on confidence of some darn thing, okay? And you're really in paired t-test world, all right? That's kind of what I see with differences. Vast majority, if not exclusively. Okay. The relationship question is a different kind of thing. Here I'm looking at two different variables, typically, okay? And I'm saying, is there a relationship between, what do I have here? Staffing ratios and patient falls. Fair enough question. And relationships, basically when you have scale variables, ratios is a number, okay? Okay. Falls is a number, okay, that okay, with equal intervals, okay, and you're in correlation land there. Prediction, different animal entirely. Here, we're trying to see, does a variable or set of variables predict or impact, okay, the some outcome variable. Okay. So quick cheat sheet. When you have study aims where you're doing paired t-test, you pre and post, both both the variables are scale, okay, just 2 time points, we're in paired t-tests. If you have a camera, take a picture of this. If you have truly paired pre-post and it's really ordinal, okay, like one item, that's 3 or 4 point, you're in Wilcoxon sign rank. The Wilcoxon is also the test when the paired t-test assumptions are not met, namely normality, okay, or exclusively normality, okay, that's the only primary statistical assumption there. You're going to do a Wilcoxon. For DNP projects, even if the assumption's violated, and both the t-test and the Wilcoxon was significant, t-test and Wilcoxon was not significant when they are similar, okay? Use the paired t-test, report the paired t-test, have the Wilcoxon in your back pocket, because means are easier to discuss than medians, okay? And t-tests deal in means, Wilcoxons deal in medians or ranks. Okay. When you're doing comparisons, differences, okay, on scale with 2 groups, you're doing independent sample t-tests. When you have 3 or more groups, you turn into an overland, okay? The differences on, confidence by teacher, administrators, parents, you're in an oval world. Association and relationships, I'm using synonymously. When they're both nominal, we're in chi-square land, 98% of the projects. When the association is scale and scale, we're doing Pearson correlations. And prediction, the key thing is the outcome variable. When the outcome variable is scale, dependent variable is scale, okay, you're doing a linear regression. And when the outcome variable is binary in nature, just 2, we're in logistic regression, okay? We do have a decision tree that can help guide you through that process. Right? Setting up your data is important. The key thing here is that each row is one participant. I see things on different data sheets. I see people in columns. Okay. This is how the data must be set up, whether you use Intellectus or SPSS or Excel, whatever you're using, you got to have one person on one row. So for nurse 1, all of their scores are on row 1. Their pre-test score, their post-test score. That's the paired t-test version. You could have uh, looking at differences on some score by some grouping variable, like intervention or control, that happens. But again, the data setup is similar in that each row is that individual. So that nurse 1, it happens to be in an intervention group and has that score. Nurse 2 is in a different group and has a score, okay? So each participant, one row, okay? And if you got to combine your sheets, you can't deal with, maybe one day, but at the moment, you have to put everything on one sheet, okay? So if you got pre-test in one sheet, from Qualtrics, and post-test on another sheet, you got to marry them together via that common ID of participant or dog's name and mother's birth date or whatever that is, okay? They have to be matched. A brief comment about statistical significance and clinical significance. Statistical significance is that common P 0.05 level. By the way, people really confuse that, and I think it's just lack of experience, frankly, that the p-value, they say, is significant. That shows a statistical difference between this average confidence score at pre and this average confidence score at post. But that's really not true. The truth is that probability level is getting that t-value, okay, the t in the t-test, okay, is getting that t-value less than 5 times out of 100 by chance. That's what that p-value refers to. The p-value is tied to that test, the t-test, or the f-test, or the chi-square, whatever. But it's tied to the value of that test. It's after that that we say the t-value didn't occur by chance, that we can then say, oh, look, the mean confidence at post was greater than the average confidence at pretest. So statistical significance, it's demanded. People know it. People can typically read it, and that's what it is. Okay. The clinical significance is a different animal. That animal is often captured by Cohen's d. It's actually presented in the t-test or in the f-test. All these tests, they have effect sizes, okay? And this is talking about the meaningfulness of that difference. So there's lots and lots of examples. I don't know if I have it here. I do. So the lots of times you can have a statistically significant difference, but it's not clinically significant, particularly with large samples, which is typically not DNP's issues, typically too few sample. Okay, but the sometimes you can have statistical significance. Okay, blood pressure, a statistically significant reduction, but it doesn't mean anything meaningfully. This is statistical significance. So, but it doesn't bend the bar far enough where it actually makes a bit of difference. Okay. Statistically significant, but not meaningfully important. Conversely, you can have something that is clinically important, falls dropped by 30%, but it didn't reach some statistical significance. And then the best part is when you have both clinical and statistical significance, where you're finding statistical differences between two sets of scores, for example, and it's meaningfully important. I'll say that often they go together, okay? When is clinical, the statistical, or when is statistical, this clinical. But a lot of times in small samples, you'll find that it doesn't meet statistical significance, but clinically it is important. And so looking at that D, or Cohen's D, is an important thing. It's worth talking about. That, hey, gosh, for future research, perhaps what I need to be doing is increasing my sample size to get statistical significance. But the fact is that it's meaningful. Okay, reducing falls by 30%, whether or not you met statistical significance or not, is really, really important. We'll talk about the tool has got, pardon me, Intellectus has got a data cleaning wizard, okay? Because cleaning data is 90% of the job. The other part, that big asterisk, big star discussion section draft, which is going to help quite a bit. Okay, let's get to the demo. I've been talking for half an hour. There's questions up here. While people logging on, let me read this. My project is to implement a release of information collection process for youth with diabetes and outpatient. Okay, there is a PICO question right there. So listen up, everybody. So here's the PICO question, and then we'll figure out what do we actually mean here. Okay. The PICO question. Implement a release of information collection process, okay, for youth with diabetes. That's inclusion criteria. Okay, that's not going to affect our stats at all. In an outpatient, okay, so in I'll read the whole thing again and then get to the root of this thing. My project is to implement a release of information collection process for youth with diabetes in an outpatient endocrine clinic. My baseline data is 0 because the consent use to be built in a diabetic medical management plan. I'll be doing educational sessions, fine, and checking the rates of completion. Okay, we got to get to the third sentence to get there. I'll be doing an okay, so and checking the rates of completion consents on a weekly basis for 6 weeks. What test do you recommend? So our baseline is 0, check, and we're comparing that to completion rates, right? So we have a rate. So we're really back up here in the differences, and we're comparing the difference between a 0 completion rate, whether or not it was 0 or not, that's another story. But for the moment, maybe we have 0, maybe we're just starting this, okay? And we're comparing that to one rate. So that's a one proportion Z test, okay? Comparing some rate, okay, versus, and I can show you. And we're comparing that to the 0, okay? All right. So, all right, so we'll get there. All right. All right, let's get to the tool itself. Let me just also, since I'm here, we'll get to, let me just, you could take a picture of this as well, just to plug in Samantha for students, Ashley for faculty, Melissa for everything else, and phone, website, and a QR code for me if you want. Okay. All righty. So let's just get some simple data in. So the simple data in process, we'll just go through this one at a time. So one, simple, enter data manually. You can paste in your Excel file or paste in your Qualtrics. All you want is the variable names, ID, okay? Pre on the confidence scale. There's been a lot of those lately. Post on the confidence scale. And you may have some, gender or sex or something. Okay. And then, if paying 2, 3, 4. By the way, some people say, wow, I have to do a Wilcoxon because my sample size is small. No, you don't. You can, I've seen small samples and I'll show you. And you have confidence scores, let's just say 1, 1.2, 1.4, 2.4, 1.8. Okay, I'm keeping these very tight in there, and 1.6. And let's just say the post confidence is 4, 5, 4.8. Okay, 4.9. And 4.5. Okay, and then gender, male, female, female. Dress me up, still can't spell. Okay, feet. Okay. Okay, simple data set. The key thing here, again, is that participant number 1, all of their scores and data are on one row. Okay. So simple. Go to, upload data. You can go to Data Cleaning Wizard. I'm going to pass over this for the moment. This just validates what we have going on. Scale, 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 nominal. Anybody want to comment on this? Okay. So sometimes a number, not sometimes, always a number is going to come up as scale, but these are just labels. This is just person one, person two. They're not in order. Okay. So these are really nominal. So you want to validate your levels of measurement to make sure that they're right. Okay. Okay. So, and you can do data management things here. The most important things are keeping those levels of measurement correct. The second thing is a variable calculator where you can create a confidence score, for example, based on some variables, and you can just do a quick mean composite or sum composite, if you wanted to average those things. So those are helpful little buttons to be had there. The other thing you want to do is that download data. Once you've created a composite score, you're going to want the you're gonna want to download that data and have that Excel file. You're going to want the file. Faculty's going to want the file. And if you publish it, the reviewer, I think they're asking for your data too. So you need to download that managed data. You can plot the data if you want. There's 10 typical plots. Very simple to use. If I want to look at confidence pre to post, okay, by gender. A line chart would be appropriate because it's the same person. Okay, if they're discrete groups, well, I'll show you in a second. If they're discrete groups, you probably want bar charts. But what you can see here is the confidence pre, confidence post. And then this is my males and females. And you can see that, hey, they're both really kind of increasing for pre to post. You can change the labels of these things. You can export it to the document and so forth. And there's other charts to be had here too. I like our charts. Um, you know, Nothing really compares to a Word document chart. Um, I think it's very simple, particularly if you want to change the axes. We can change colors, you can do other things, but so this will get you through the night. But I think, for me, I can, make, a word chart sing. So these are good. They're in the tool, but heads up. Okay. Here's our analysis palette. It really ranges. Most of you will be using descriptives in nature. Okay. Correlations, proportions tests. We'll get to that one that we just had there. Paired t-test or independent sample t-test. There's ANOVAs and regressions and other things, but okay. So let's just do a few things. First thing is always both run descriptives and read what you got, okay? Sometimes I run them, but then I don't read them, and then I pay the price for that. So you put in your variables and hit calculate, which I'll do in a second. Know that for all these different tests, there's two things catty corner that we should look at. One is options. You probably don't got to mess with that, but know that you can put in or take out different variables in that. The other thing is that in each one of these dialog boxes, there's a 2 or 3 minute video tutorial. There's probably 80 of them that you can have there as well. So conduct the test, add to the analysis document, and then read it, which is, okay, I have 5 people responded, hunky-dory, the N and the percentage of that, okay? The scale variables, confidence pre, mean 1.6. The key thing here is the min and the max. If your scale went from 1 to 5, but you happen to have a 55, you just made a data entry error, okay? No problem. Correct it. Go back and correct it before you go do other things. So it's important to look at those mins and maxes to make sure everything is cool there. prior to moving on, okay? All right. Then typical use case is paired sample t-test, where I'm comparing the confidence at pre to the confidence at post. Notice the icon, it's only going to allow scale variables. And then hit calculate. Add to the analysis. So here, for all of these tests, the assumptions are built in. Normality is the assumption of the paired t-test. It conducts the test and then interprets the test for you. Put in your own voice, but you got some accurate interpretation going on here. I should note too that this is not driven by AI. This is purely driven by R. So all of those numbers are spot on, dead on. The results of the test, even with a sample size of 5 all, was significant. Okay, here is the t-value, which of 13.51 minus 13.51, and that t-value will occur by chance of 1 in 1,000. Okay, that's what that p-value indicates. Most DNPs don't use hypotheses or do research, so you won't need that phrase, okay? Once you know that that t-test is significant, you can state that, hey, gosh, yeah, confidence scores increased post some intervention and that baseline or that pre, okay? That D that we talked about earlier, the effect size is sitting there. To give you some context, the anything north of 0.80, okay, 0.50, 0.80, somewhere in there, is a large effect size or meaningfully important. 6 is off the charts, okay? So it's both statistically significant and meaningfully important, okay? And it's kind of a bar chart to kind of show you that. Those mean differences. It should be heads up too, by the way. Um, Make sure you look at the axes. So here the axis starts at 0. Sometimes they start at the 1, and it doesn't look like a big difference. Well, you're starting at 1 or you're starting at 50. So just be mindful of that, okay? What you're looking at. All right. Okay, the other quick thing, and it does come up enough in the one case of some rate of some sort of completion rate or something of that sort. It's a one proportion z-test. When you compare it to a number, this rate compared to a specific target number like 0, that's a one proportion. More often, it's well, let's just do this. So I want to compare, my rate. You have to know the sample size, 55. And let's just say my proportion is 30 or whatever that rate is, okay? And then comparing it to 0, it could be some other test proportion or test target, okay? But for this particular test, I'm comparing a proportion completion rate, okay, of 30%, okay, to 0 to see if that's statistically different from 0. And here you can see there's a normality assumption in there. It was significant, okay, which basically is indicating that, hey, guess what? That 30% is different than that proportion of 0, okay? More often than not with this rate business, there is a rate before and a rate after. So you can have, rate, whatever, fall rate, pre, sample size 55. Maybe the fall rate before was 0.80. Staff were out there tripping people, obviously. Okay. Or more likely, definitely more likely, they're on the wrong meds, right? And they're getting, right? They're out of pain, but they're falling. And you want to compare that to some other rate, fall rate post with some intervention, non-narcotics. This rate happens to be 40, and proportion rate has dropped down to 10%. So now we're really testing differences in proportions of a rate of 80% falls, okay, leaving strings all over the place, to a proportion rate of 10, right? That's the question at hand, and that's the analysis to examine that question or aim. And here, there's an assumption of normality. We can also see that was significant. And the implication is that the that proportion of 80% does differ than that proportion of 10%. You have to run the test though. It seems quite obvious that 80 and 10 are different until you get to weird sample sizes. That is to say, small sample sizes. Maybe this proportion was 5, and maybe this proportion was 2. Okay, I'm still comparing 80% to 10%, but I have different sample sizes. Um, still statistically significant. Okay, fine, but my point is going to be the same, which is with different sample sizes, it can change that significance level greatly. Okay. Um, so again, by eyeballing it, you would think, well, that's absolutely the case. So let's do one more of those.
We also have a question about significance for the paired t-test and then maybe some shared projects.
Got it. Thank you. Here, again, 30% versus 10%. Again, I would say, boy, that seemed like a big difference. Reducing falls from 30% to 10%, that seems like it should be significant, but it's not. Okay, so just be mindful of the sample size. Okay. So Will, hi Will. So if the paired t-test is not significant, then you go to the Wilcoxon. Not necessarily. So the t-test, if the assumption is, so I'll try to keep it simple. If the normality is met, you want to evaluate the t-test and let that be wherever the cards fall. If the cards fall significant, great. If the cards fall non-significant, great. Okay, you just use that t-test. The only time you go to the Wilcoxon is if normality is violated, okay, or not met, okay. Then I would be doing some comparison between the similarity between the t-test and the Wilcoxon. So the short answer is assumption is met, use the t-test, call it the way it is. If the assumption is not met, evaluate both the t-test and the Wilcoxon. All right, you said there was other questions? You're welcome.
Just maybe shared projects.
Okay, thanks. Let me refresh. I don't see any, unless they put it in before.
Okay.
Okay, other questions? Esther raised her hand.
Yeah, I'm gonna.
Hi, Esther.
Hi. Oh, thank you so much. Um, so
Pleasure.
I sent my spreadsheet, my Excel spreadsheet with my data because I tried to use Intellectus and I got I had the result, but it seems like you answer some of the question. But if you don't mind, just upload the my sheet, and then I'll show you something because I was trying to clean up the wizard. Um, uh this is the dictionary, yes. So we talk about this. I didn't have a lot like a big sample, even though we
Right.
don't use sample in nursing. We say number of participants. That's what they want me to use. So but I have a question about the BB. If you see the Berger balance score on the pre, I'm missing at line 3. It doesn't help. I don't know how to put the data there because it keep putting like a name. I want a number. I don't know how to do it. And I ran the test. I have some result, like you just explained, an assumption. I did a PERT test. And yesterday, on Tuesday, I think it was Samantha who said that I had some, my assumption was violated, and then she didn't know how to help me. So I'm here for your help.
So I'm just going to copy that data.
Mm-hmm.
Okay. I'm going to go into enter data manually and paste. Okay. So let me save this. So we're comparing BBS pre to BBS post or BBS
Yes.
pre to mid to post.
Yes.
All right. So the first question is, is this truly missing or do you actually have
No,
the
I
data?
have a data, but every
What's
time
the
I keep,
number? What is it?
it was 15.
Okay. And how about a post?
The post, since the person didn't do anything, it was still the same.
Well, they did something here. Same as the
Yeah,
pre or
but
same as the
at
mid?
the end, they decided to do just the part of the exercise.
Do you have a number for this or not?
13.
Okay. That's going to mess you up. Did they, let me just validate that.
Mhm.
So they actually did have a score or you think they had a score?
They have it.
Okay, fine. No problem.
Mhm.
All right. So fine. So once we put that in there, so okay. So again, you want to clean up a little bit. Okay. This is
Yeah.
really male or female.
Yeah, female. All the rest were just female.
No
The
problem.
one male refused, and then it was like attrition.
No problem. My point for the folks in the call that get the levels
Hmm.
of measurement right. This
Yes.
level, that's a number. Okay. So you're gonna make that scale.
Yeah.
Doesn't
Okay.
like my blank. All right. Let me just make my life easy here. Let's get rid of that row. I'm just right clicking, removing row.
Hmm.
Okay. Nevertheless, that's a scale variable. Okay.
Yep.
I'm gonna put that right back into the same variable. And post is also a scale variable. Okay. I'm gonna put that scale into same variable. And then really we're off to what's the next thing we do?
So now we have to do the descriptive, the test to
Good
analyze.
job. Yay. Yes.
Mm-hmm.
All right. So we do descriptives
Mm-hmm.
pre and post because you may have more than four
Yep.
people on the call and you want to just make sure, hey, gosh, 15 to 26, 13 to 45. Does that seem right?
Yep.
Fine. And four is the sample size in each.
Mm-hmm.
So great. We validate that. Now go on to the t-test. So
Fair.
at t-test, we're going to look at pre versus post. Okay. Pre, the post. So, um, normality was violated. It's going to get to Will's question too. Normality was violated, just noted. Okay.
Mm-hmm.
The t-test was not significant. That t-value has got to be 0.05 or less.
Mm-hmm.
Noted. You have an assumption violation. T-test is not significant. Heads up on that big D. This is exactly what we're talking about. Okay. So the importance of that difference is huge, although it didn't reach statistical significance.
Mm-hmm.
Okay. Now, when that's violated, it's worth looking at the Wilcoxon. Here, it's also not significant. Okay.
Mm-hmm.
Looking at the medians and ranks. Okay. So when that's the case, when that's violated, I'm looking at both t-test and Wilcoxon. But now I'm also looking at, hey, they're both non-significant. When they're both non-significant or both significant, when they similar match when they match, I would
Mm-hmm.
just report the t-test because I
Okay.
can understand what 19.25 means. I understand what an average of 34 means, okay?
Mm-hmm.
Here, what in God's name is a rank of 40? Okay, or 8. So this is more difficult to understand how ranks work. Medians you can figure out, but ranks is not so easy. So
Mm-hmm.
so in your particular case, I would say report the assumption violation, report the t-test. It was not significant or marginally significant. I'm okay with that. And that the effect size is large. Okay.
Okay.
Importantly, you want to go to discussion draft. Okay.
Yep.
When you run a discussion draft, I'm not going to run the whole thing here because we're running out of time, but you want to put in your name, add the study aim, purpose. This is probably off. This probably should not be. Oh, research problem, research question, or study aim here. Okay.
Mm-hmm.
You want to fill those out. And then what you're going to get, and hopefully I have it relatively, uh, sorry, I should have this, sorry for my scrolling. Discussion demo. So this is just a data set. Here's some analyses. And the discussion draft, though, will come out and will have an introduction. It'll have a whole summary of your findings,
Mm-hmm.
interpretation of your findings in context with other research, theoretical implications, practical implications, limitations, conclusions and recommendations and references. This is AI driven, you got to check it, you know. So, um, so anyway, avail yourself to the discussion draft, okay? But
Mm-hmm.
for you, those are the results, okay? Did you, let me see here. Hang on. And I should do this. So, and to share this, which I will do with you now, for
Mm-hmm.
faculty or students with faculty, you can just share the project, put in your email address. Sorry if I'm putting in your email address publicly here. Share the project, okay? And then you'll get an email when you get on here. Over here,
Mm-hmm.
we'll say to accept or decline. Do that,
Mm-hmm.
okay?
Yep. Mm-hmm.
And then immediately duplicate it.
Okay.
So you need to have it as my project, okay?
Okay.
All right, does that help?
Yeah, thank you. But my other question is, so I have to do it for each, like I'm doing the BBS pre and post and then tag because I did the tag. the tiger got the thing, but didn't know how to bring the discussion, and also the fall, the 6 months prior, and then the during, because the during, that when we did the implementation. So I have to demonstrate how I reduce the rates of fall between like before and after implementation of the exercise Otego.
So I think you still do a paired t-test there.
Okay, so each one I have to like do like for the fall
Yeah.
rate, and then generate another discussion.
Generate another analysis, that discussion, waiting till you to conduct all your analyses, and
Okay,
then run a discussion.
okay. Thank you.
My pleasure. My
Mhm.
pleasure. Have a good rest of the week.
You too.
Thank you. Other questions? All righty. So let's just kind of wrap up here. Um, we did this. Again, we're here to support you. I wish you well in your DNP projects. If you're faculty, happy to help out to work with your own either internal data or data for a journal article and kind of work through that, okay? All right. Other final thoughts, questions, Melissa?
Nope, I think we're all set.
Terrific. Everyone have a good rest of the day and stay safe and happy. All right.